Okay, today we're going to learn how to perform a chi-square goodness of fit test in Excel, and we're actually going to go through an example in the lecture notes on page 2 involving the Hershey Company. So if you want to pull out your lecture notes, flip to page 2, we're actually going to run through the example. So first thing we're going to do is just say we're going to look at the Hershey Company, and we want to determine if customers have a preference for any of the following three candy bars. So we have three types, A, B, and C. A is Mr. Goodbar, B is Hershey's Milk Chocolate, C is Crackle. Let's just do some slight formatting adjustments here. Okay. So we know that we're going to have a random sample of 140 consumers. So what we can do is say we're going to have a total of 140 consumers. And we know of this 140, we have 43 that preferred Mr. Goodbar, 53 that preferred Hershey's Milk Chocolate, and 44 that preferred Crackle. So if we sum these values, we're going to get 140. We know we match. And now we can actually jump into finding out how to test the null hypothesis that customers have no preference for any of the three candy bars. So essentially what this means is that the hypothesized proportions are all going to be the same. So we can go ahead and label this column, and we're just going to do some quick formatting. Just wrap this text. Okay. Now we know we have three different types of candy bars, so we can just simply compute 1/3 for hypothesized portions, and we're just going to go ahead and convert this to 2 decimal places. Now, next we have to compute our expected counts. And the way we're going to do this is simply by taking our hypothesized proportions, just computed here, and multiplying them by our total number of consumers. So the way to do this is we're just going to take 1/3 times 140, and in this cell we're going to lock it using F4 to make sure that when we copy this down, we will not be moving that cell. So now you can see that our expected counts are now equal the total in the table on page 3. Now, we know that our alpha for this test is going to be 0.05, and what we want to do is test the hypothesis using this alpha level. So we ultimately want to get a statistic. Now, the way to do this is take our observed minus our expected over our expected. There we go, that should work. So we're going to take, let's rename this column. So we know that our consumers are actually our observed counts. We've identified that this certain amount of consumers, we know that given our random sample, prefers Mr. Goodbar, Hershey's, and Crackle. Now, we know our expected based on the hypothesized proportion, so we compute this difference. We take our observed minus our expected, square that, and simply divide it by our expected here. So we should get the same number, 0.288, and we can go ahead and round this to 3 decimal places. If we copy this down, we will actually, with the beauty of Excel, be able to see that we have the same values for Hershey's and Crackle as well as in the table. Now, in order to get our test statistic, basically we're just summing these values. So we should get 1.3. And we can go ahead and label this. And we can go ahead and label this as well, so we know that we won't get confused. Now, in order to actually do the test, we're going to use the function chi-dist. So let's go back into our sheet here. So we need to find out our degrees of freedom, and this is simply going to be k minus 1. So our degrees of freedom, we know we have 3 jump bars, so we're just going to say 3 minus 1. Our degrees of freedom are therefore 2. So now, using the chi-dist formula, I'm using a later version of Excel, so if you just type this in, you should be able to see your x value. Your x value in this case is simply your test statistic we calculated, and your degrees of freedom are going to be 2. So if we move this formula over, we now have computed our probability, p-value. We can confirm this using the Minitab output. We know our degrees of freedom are 2. We know our sample is 140. So we've just completed our first chi-squared test in Excel.